Well, hello there, ladies and gentlemen. It's time to use one of these and one of these. A protractor and a Dixon Ticonderoga number 2. Hashtag not sponsored. All right, let's do this one. Ready? Man, I'll do my best to try to capture as much of the paper as I can. Let's see here. Here we go. All right, so here's what we got. We got some transformations, some geometry. Oh, yes. So, we've got these three shapes, A, B, and C. They're all triangles. It says, draw the image of shape A by the transformation vector -6, -4. Now, that's change of x and then change of y, like this. So -6 is 6 to the left. So we have to go 6 to the left, and then we're going to go down 4. So each one of these points will be translated that way. Now, this is a nice graph because each of these lines is 1. It's often the case that these are halves, and people actually do 3/2. And that's not so good. So 6. So 1, 2, 3, 4, 5, 6, and then down 4. So 1, 2, 3, 4. This point here is going to be right there. And then it looks like I got 2 down right there. And so this would be my shape. Let's use the protractor. Make nice, pretty straight lines, just like all of you. Now, in the United States, we will often call this A prime. They don't really ask us to label it, but yes, there we go. So that's a translation of 6 and -4 to the left and then down. So x, y. Draw the image of shape A of this one after rotation of 90 degrees clockwise, so that's this way, about the origin. Ooh, 90 degrees clockwise about the origin. So check this out. If I were to put a pivot point right there at the origin and then rotate clockwise 90 degrees, you see how it looks? Oh, interesting. So it's going to look like this. So 90 degrees. So 90 degrees would be like right here. And then, so it's going to look like this. Oh man, I should have used my ruler. Come on. If you make it look neat, the people that are grading it are going to think that it's going to make it easier for them to grade. They're going to be happier. They're going to give you the benefit of the doubt. You know, none of those things should happen, but that's kind of how it does happen. So anyway, there we go. 90 degrees. 90 degrees. So, you know, I did this right here, 90 degrees. Helped me figure out where one point was, and then I saw how it looked when I did the transformation by moving the whole paper. All right. Describe fully the single transformation that maps A onto B. A onto B. Well, you see how this changes the size from A to B? That tells me that this is going to be, hold on, let's see here. Oh, man. Look at that. Look at that blister. It used to be all the way over here. Oh, burnt myself with a Dutch oven. The pad slipped. Oh, terrible. Terrible. Anyway, we're going to map A onto B. I think I've done too many of these videos today. So that's an enlargement. And do you see how this is worth 3 points right here? That's because we have to first name it enlargement. United States, we often call them dilations. That's 1 point, right? So you have to name it. That's 1 point, and then you have to give the scale factor, and then you have to give the center of enlargement. Okay, so we've got to give all 3 of those things. Okay, so let's find the scale factor. So the scale factor to me looks like it's a scale factor of 3 because this is 1 across, and that's 3 across. This is 2 across, is 1, 2, 3, 4, 5, 6 across, you see? So the way we can find the center of enlargement is we can connect all of the dots. Ah, I see, okay. Um, Okay, let me re-describe what I mean by connect the dots. You see this point right here? It's corresponding to that point right there. I need to draw a line through those two. Same with this one and this one. Now those are collinear, so it doesn't really do much for us. But this point and this point, and then where it crosses, that's the center of enlargement. So that's 3. Um, let's see, center at 3 comma 3, and the scale factor is going to be 3. It's 3 times larger. And another way you can tell that is the distance from here to here is going to be from here to here. That's a distance of 1. From here to here is 3. See, 1, 2, 3. So that's 3 times as big. All right. Now, Last one we got is we need to do A on to triangle C. So from A to triangle C. All right, so that's worth 3 points as well. A on to C. So that to me, well, that's kind of strange. You see how the shape is different? It's considerably different. Sorry, let me move my phone out of the way. I'm popular today. So A on to C. You see how it's stretched, and that's what it's called. It's called a stretch. Now, for a stretch, we also need the factor, the scale factor, and then we need the line of invariance. And you get 1 point for each. So, oh, sorry. So it's a stretch. You get 1 point for the name. We got 1 point for the name. It's an enlargement. This one's a stretch. You need the factor and then the line of invariance, and that's why it's worth 3 points. Okay? Let me get this a little better focus for us there. Okay, so you see how it doesn't change this way? So that means it's stretching that way. And the scale factor, let's see, that's 1, 2, 3. So the factor is going to be 3. I think, hold on, before we do that though, let me see if I can figure out, since that's a scale factor of 3, I think that this is the line of invariance right here. I think it's the y-axis. Because look, the distance from there is 1, and the distance to there is 3. So that's it right there. So factor of 3, and let me see, make sure we can see this. So this is where I'm guessing the line. Like originally, I was guessing that the y-axis was the line of invariance. So it gets stretched this direction, right? That's why this distance stayed the same, but this one changed. It went from a distance of 1 to a distance of 3, which tells me the scale factor is probably 3. And so then I just guessed that maybe the y-axis is the line of invariance, and it works out. It checks out because this is a distance of 1, but from here to here is a distance of 1, but from here to here is a distance of 1, 2, 3. Scale factor of 3. Line of invariance is the y-axis, or you could say x equals 0. Man, that was some fanciness right there. That is it for number 6. Number 7 is just a whole ton of fun. We'll get to that one later. Hope it's been helpful. You guys are wonderful young people. Have a good day. Until next time, be safe. I'll see you later. Have a cookie for me or something, all right?